We are looking at the Math 2 Unit 12 review worksheet. This unit focuses on volume of solids. So we're going to start with some area review here. So we have a square with side of 17 centimeters. Now if you remember, in a square all sides are the same, congruent, and we also have some right angles. So our area, you can either set as the side length squared or its base times height. But since they are the same, it's just 17 times 17. So that gives us 289, and that's going to be centimeters squared because it's squared units whenever we're talking about area. For the next one, a circle with diameter of 17. It's a good idea always to draw these first. So it's 17. Now in a circle, our area is pi r squared. So take half of the diameter. Half of 17 gives us 8.5. So we're going to do pi times 8.5 squared. 8.5 squared gives us 72.25 pi. Now that's going to be centimeters squared, but it asks us to round to the nearest tenth, so we're going to multiply by pi. So times pi gives us about 226.98, so we're actually going to round that to 227 centimeters squared. Pay attention when the question, what you need to answer it in terms of pi or rounding as needed. Number 3, a triangle with a base of 8 centimeters and a height of 4. Area of a triangle is 1/2 base times height, so we're going to do 1/2 8 times 4. 8 times 4 is 32, half of that is 16, and that's 16 centimeters squared. Number 4 is an equilateral triangle with side length 30. So if each of these are 30, and we know the area is base times height divided by 2, we can go back to our 30, 60, 90 days, cut this triangle in half. We have 30. And this is a 30, 60, 90 triangle. Our rules for that was 1, 2, root 3 for the ratio. So we know that this side opposite the 30 is half of the hypotenuse, so that gives us 15. And then the short side to the long side is to root 3, so that's actually 15 root 3. If you don't remember that, you could use Pythagorean theorem from here as well to help you with that. So we have our base is 15, our height is 15 root 3, all of it over 2. So 15 times 15 is 225. We got 225 root 3 over 2. So we're going to round that to the nearest tenth. So times the square root of 3 divided by 2, and it comes out to be about 194.85. So we're going to say that's about 194.9 centimeters squared. For number 5, the circumference of the circle is 8 pi. So our formula for circumference is 2 pi r. So that's 8 pi equals 2 pi r. Divide both sides by pi. Divide both sides by 2, and we get to 4 equals r. Now we need to find the area of the circle, which is pi r squared. So that's pi times 4 squared, or 16 pi centimeters squared. Now that is our answer in terms of pi. Now we need to round to the nearest tenth. So we'll do 16 times pi, which gives us 50.265, so we'll go 50.3 centimeters squared. For the next problem, we have our first volume problem. And so the volume of a prism, and this is a triangular prism, it's the base area times the height. We have to remember B isn't just base. When it's capitalized, it's the area of the base. Now the base is this triangle, not a rectangle. So to find the area of the triangle, it's 1/2 7 times 35 times the height of the prism. And the height of the prism is how far the bases are away from each other, and so that's 18. If you don't put the 1/2 in, you're going to get the wrong volume. You'd actually get the volume if it was a prism, and not a rectangular prism, and not a triangular prism. So we're going to multiply. So we're going to do 7 times 35 divided by 2 gives me 122 0.5 times 18 gives me a volume of 2,205 millimeters squared. For the next one, number 7, we have the volume and we need to solve for a missing value. So volume in our prism is base area times height. So we know it's 126 for the volume. The base area is 1/2 3 times 3 because this is again a triangular prism. We're multiplying that by the height, which is x, and that's how far away the bases are. And that's another way to think of the height. It's the distance between the bases. So that's x. So we got 126 equals, make this 1/2 times 9 times x. This also becomes 4.5 because that's half of 9. So I'm going to divide 126 by 4.5 and I get 28. So 28 centimeters is my value of x. The next problem works the same way, but if you notice it's rotated now where we have our base here. So let's set it up. Volume is base area times height. So 132 equals 1/2 4 times 6 times the height x. So we have 132 equals, this is 1/2 times 4 times 6. 4 times 6 is 24, half of that is 12. So now we're going to do 132 divided by 12, and we get x equals 11 inches. On to the next set. Now we have some cylinders here. They want our answer in terms of pi and round to the nearest tenth, so we can give both versions. Our formula for cylinder is pi r squared times height. So we're going to do pi times 7 squared times 12. So 7 squared is 49 times 12 gives me 588 pi centimeters squared. So that is our answer in terms of pi. We now multiply that times pi and we get 1,847. It's 0.256, so we're going to go 0.3 centimeters squared. Next problem, 18 is now the diameter. So our volume is pi r squared times height. So we're going to do pi times 9 squared times 4. 9 squared is 81 times 4. We get 324 pi inches squared. Multiply that by pi, and it comes out to be about 1,017. Now 0.87 is going to become 0.9 inches squared. For number 11, we want to think of this as like a square donut. We're going to find the volume of the outside, and we're going to subtract the volume of the inside, and it's going to give us that donut-looking shape. So the outside is a prism, so the volume of that one is 4 times 3 times 4. The volume of the inside is 2 times 2, and then its depth, this distance, is 3. So 2 times 2 times 3. So we have 4 times 3 times 4 gives me 48. I'm going to minus 2 times 2 times 3, which is 12. So we get 36 feet cubed. Next problem, same idea. The volume of the outside is 6 times 12 times 6. We're going to subtract from that the volume of the inside, which is 2 times 2 times 12. So 6 times 12 times 6 gives me 432, minus 2 times 2 times 12, which is 48. So 432 minus 48 gives me a volume of 384 feet cubed. For number 13, we need to find the value of x if the volume of our prism is 135. So volume is base area times height. Now to make this easier, let's just think of this as the base, because now it's a square. So 135 is equal to x squared it's x times 15. Now I can divide both sides by 15, and I get 9 equals x squared. If I take the square root of both sides and take the positive solution, the answer is 3 centimeters. For number 14, we need to find the volume of the cones for 14 and 15. So that's 1/3 pi r squared times height. But the important thing we have to find here is we want the actual height and not the slant height. In both of these problems, they give you the slant height. So what we have to do first is Pythagorean theorem in order to find the height. So in this triangle, let's put an h right there. I have 5, 4, and h. So I'm going to go 5 squared equals h squared plus 4 squared. And 5 is by itself because it is the hypotenuse of our right triangle. So 25 equals h squared plus 9 becomes 16 equals h squared, and h equals 4. So now 1/3 pi r squared. Oh, we did something wrong here. Back up. Try that again. We get 25 equals h squared plus 16, which is 4 squared. That becomes 9 equals h squared, so h equals 3. I started doing the problem in my head as I write it down. So height is 3. So we got 4 squared times 3. Now when simplifying here, I could multiply 4 squared and then divide it by 3, but those don't divide nicely. 3 times 1/3 is actually 1. So that actually becomes a 1, and now I'm left with 16 pi centimeters squared. So that is the answer in terms of pi. Now we do 16 pi in our calculator, and we get about 50.3 centimeters squared. For the next problem, we need to do Pythagorean theorem again. We have 7, 5, and our height. So 7 squared equals h squared plus 5 squared. 49 equals h squared plus 25, and that becomes 24 equals h squared, or h is the square root of 24. Now I'm not too worried about simplifying this down because they want the answer in terms of pi n to the nearest tenth, so let's see what we can do here. So volume is 1/3 pi r squared times height. So the radius is 5 squared, and the height is square root of 24. So this becomes 25 square root 24 pi over 3. Maybe we should look at 24. 24 is 4 times 6, which gives us 2 2's, so that becomes 2 root 6. So 25 times 2 root 6 pi over 3 leaves us with 50 root 6 pi over 3 feet squared. Technically, that is the answer in terms of pi. Now, let's just get a decimal. So we're going to go 50 times the square root of 6 times pi, then divide that by 3, and we get an answer of approximately 128.3 feet cubed. Not squared, should have been cubed. Oh, I'm writing the units wrong. Should be cubed there. For number 16, we're now finding the volume of the square pyramid. So we have the base edge is 16, and the slant height is 10. Like the problems before, we need to do Pythagorean theorem. So 8 is this bottom side because it's half of the 16. This is 10, and we have to solve for height. So 10 squared equals 8 squared plus h squared. 100 equals 64 plus h squared. We get 36 equals h squared. So h is 6. So now our volume is 1/3 base area times height. Our base area, because it's a square, is 16 squared, and our height is 6. So 16 squared is 256. Now, 1/3 of 6 is 2, so I could just make this 256 times 2. And that comes out to be 512 centimeters cubed. For number 17, same process. The base edge is 13. The slant height is 12.8. We just have decimal values, so let's see what we get here. So we got 12.8. We're looking for the height. this would be 6.5. So we'll go 12.8 squared equals 6.5 squared plus h squared. 12.8 squared is 163.84. 6.5 squared is 42.25 plus h squared. We're going to subtract, and I get 121.59 equals h squared. We take the square root of that, and it comes out to be 11.026. So it's like 11.03. So that is our slant height. So our volume is 1/3 base area times height. So 1/3 13 squared times 11.03. So 13 squared is 169. Let's multiply that by 11.03. And then divide all of that by 3. And we get an answer of about 621.4 inches cubed. For number 18, we need to find the diameter of the sphere with volume 2,304 pi centimeters cubed. So diameters here, we actually going to find radius first. So let's use that. 4/3 pi r cubed. So 2,304 pi equals 4/3 pi r cubed. First thing we do is divide both sides by pi. Takes care of that. Now I'm going to multiply both sides by 3 to get rid of the denominator. So 2,304 times 3. This means 6,912 equals 4r cubed. Now I'm going to divide that by 4, and I get 1728 equals r cubed. For the last step, I have to take the cube root of 1728. There's a couple ways you could do that. Some of your calculators have the cube root button. Other ones, we just have to do the exponent. So for this, I'm going to do 1728 to the 1/3 power, which comes out to be 12. You can also sometimes use that cube root button like I have right here, where I could type in the 3. Let's see if it works this way. That also came out as 12, and sometimes I just have the 3 there. So we get to 12. That's our radius. Ask for diameter. So the diameter is 24 centimeters. Last page. Find the diameter of the sphere with a volume of 288 pi. So same process. 4/3 pi r cubed. So 288 pi equals 4/3 pi r cubed. I'm going to divide both sides by pi. I'm now going to multiply both sides by 3, so 288 times 3, then divide it by 4, and I get 216 equals r cubed. Here we're going to take the cube root of 216. You could always think of this as what to the 3rd power is 216, and you might have some of those memorized, but this one, if we do the cube root of 216, it comes out to be 6 inches as the radius, so diameter is 12 inches. For number 20, we're comparing two spheres. One has a radius of 9, one has a radius of 18. And we have to see how the volumes compare. So there's some relationship between the two, because we notice what we're doing is we're doubling the radius. So the first one, the volume of A, is going to be 4/3 pi times 9 cubed. And the volume of B is going to be 4/3 pi times 18 cubed. So 9 to the 3rd power is 729 times 4 divided by 3 gives us 972 pi. I'm not going to multiply by pi because I'm really just comparing, so we're going to leave that there. 18 to the 3rd times 4 divided by 3 is 7,776 pi. So before it looked like they doubled in radius. Now let's just divide the volume of B by the volume of A and see if there's a relationship there. Now, they both have pi, so I'm going to divide with a pi in it. So I'm going to go 7,776 divided by 972, and I get 8. So that tells me that when I double the radius, the volume is 8 times larger. All right, number 21. We have our volume. We have our formula here in our diagram. So that is base area times height, because it's a triangular prism. If this is 14, I need to know these two sides. Now this is a 45, 45, 90 triangle. And if we remember from that, the relationship was root 2, 1, and 1. So if I want to find x, I can use a proportion here. So we could go 14 is to root 2 as x is to 1. So that would give us just x equals 14 over root 2. We rationalize the denominator, and we get 14 root 2 over 2, which is 7 root 2. For number 22, we have two cans, one tall, one short, that bury the base of both cans is 2 pi. So that's not the radius, that's the actual area. So now we're going to use that to get to talk about volumes and the height, because all we have left really is the height and then the total volume. So the volume of the tall can is 18 pi. Now, the volume is also pi r squared times height. This is pi r squared because it's the area. So that's 2 pi times h. So if I said 18 pi equals 2 pi times h, that means h is 9. Then the short can is 3 centimeters shorter than the tall can, so that's now 6. So its volume, instead of saying pi r squared times height, we're just going to say 2 pi times height, or 6, gives us a volume of 12 pi centimeters cubed. So it's using that idea of we don't have to know the radius, we just already know the area, because a cylinder, similar to a prism, is base area times height. For number 23, the radius of our sphere is 12. We need to find the volume of the sphere and answer in pi and to the 10th. So we're going to do 4/3 pi times 12 cubed. So 12 to the 3rd power is 1728. Let's divide that by 3, then multiply it by 4, and we get 2,304 pi centimeters cubed. Multiplying that times that pi, and it comes out to be 7,238.2 centimeters cubed. Last problem, we have a sphere of ice cream. We have a cone in a cone shaped, and we want to see if the volume, which one is larger, because if we have the sphere here of ice cream and it melts, its volume would take up space, and we want to see if it's going to overflow or it's going to fit in there. So let's do the volume of our sphere. Now that's 4/3 pi r cubed. They told us its diameter is 4, so that's 4/3 pi times 2 cubed, because the radius is 2. So we get 4/3 8 pi, which is 32 pi over 3. I'm going to stop there and not keep going, because this is something I can compare with. Let's see what we get with the cone. So the volume of the cone is 1/3 pi r squared times height. So the sugar cone is 10 centimeters deep. That looks like a height to me. And has a diameter of 2, which tells me radius of 2. So we're going to go pi times 2 squared times 10. So 2 squared is 4, times 10 is 40 pi over 3. So the cone is bigger than the sphere, so that means the ice cream will fit. So if all the ice cream melts into the cone, how much of the cone can be filled with whipped cream without overflowing? So now we know, well, how much extra is left. So now we're going to do volume of the cone minus volume of the sphere. That's 40 pi over 3 minus 32 pi over 3. leaves us with 8 pi over 3. Now, in terms of ice cream, 8 pi over 3 doesn't tell us much, so let's do 8 pi divided by 3, and that is about 8.4 centimeters cubed. And so that's how much volume is left for the whipped cream.